Okay, so last class we were using the coordinate plane over and over and over again for finding those angles, and then over and over and over again for finding the trigonometric ratio that they asked for. Let's see. I think I still have it open. Let's find out. Nope, that's a different class. And come on, load. Come on, load. Nope, different class. Okay, I don't still have it open. There is something that we need to notice about when we find the trigonometric ratios about the picture. I'm going to go find these trigonometric ratios. Okay. Just going to flip through. These are the answers from last night. I'm just going to flip through real fast, and we're going to notice, hopefully, notice a pattern. Okay? When we look at, starting at number 19, when we look at the O, when we look at the opposite, in number 19, the opposite is that -2. What coordinate of the ordered pair is the O? X or Y? It is Y. Okay. Look at number 20. The O is 3. Which coordinate from number 20 is the 3? Y. Find another. Here's another O. In number 21, O is -2 square root 5 out of XY. Which coordinate is O? It is the Y value. Let's see, that one doesn't have an O. Number 23 has an O. Which coordinate? O is -9. Which coordinate is O? The Y. Do you think that's coincidence, or do you think that's a thing? Just curious. What do you guys think? Coincidence, or that's the thing we should know? That's the thing we should know. Okay, so we're gonna make some shortcuts here in our notes today. We're gonna look at writing the formulas a different way. So the first thing is when we see the opposite, the O, that is always the Y coordinate of that ordered pair. So now let's go back, and we're going to look at what's the next thing? A, adjacent. We're going to look at these answers from yesterday, or last assignment, whenever you did it, later today. And we're going to look at what the A is. Look at number 19. A is, what's A? A is -2 square root 3 for number 19, -2 square root 3. What is that from the coordinates? That is the X. How about 21? A is 4. Anyone? X, what do you think? Let's just make sure with one more. Let's find one more A. Here's an A. A is square root 17. Which one's that? X, every single time. So let's write that the adjacent is the x coordinate. Thank you. All right, so now we have to talk about the hypotenuse. Now we got to talk about the hypotenuse. So I'm going to go ahead back to this assignment. And here's two of them that have the hypotenuse. They're kind of zoomed out, though. Maybe I'll find two in a row, if there is two in a row. Here. Those are kind of related, though. Meh, it's okay. Here's two that have the hypotenuse in it. Let's figure out what the hypotenuse is going to be. What can we say about the hypotenuse? What do you think, Amar? It's the longest side, of course. So it's not x and it's not y. So what can we say about the hypotenuse? What's the hypotenuse? According to the picture, according to the coordinate plane, what's the hypotenuse every time? What is that thing? We learned a vocab word. That is a thing. It's a blue line that I put a dot at the end of. It has a red arc leading to where it goes. It starts with a T. Do you remember what it's called? It's in our notes from last time. You guys drew that line, right? A bunch of times up here. Did you draw that line a bunch of times up here? This blue line? Did you draw it? What's it called? Ashlyn? Oh, no. Well, what's this? I can't tell if you guys can see. Can you see where my little cursor is? What's this line called? This blue line right here. I heard somebody talk about it. I don't know who talked. Theta is the angle. So it's not theta. You can see how theta I wrote in pink. Jackson? Terminal. Okay, so the first one is the initial, the starting side, and then the second one is the terminal side. So the hypotenuse every single time is that terminal side. Now, if you're not going to remember terminal side because you didn't remember it today, maybe in your own words, write something there so that you know terminal side and what it is talking about. Of writing these 6 trigonometric ratios. So we've got the coordinate plane, and then we've got this initial side, and then we rotate somewhere, and we end up with a terminal side. Now what's happening is we could rotate anywhere at all. We could rotate anywhere at all. And if I kept rotating over and over again, this is going to make any point along here. Oh, and that wasn't a very good drawing, but can you guys tell me if I lined up every single point that could possibly be a terminal point on the terminal side, if I lined up every single one of them, what would I create? I would create a circle. So in the circle, this terminal side is something special about the circle. What is it? It is the radius. So I'm going to add on to hypotenuse, terminal side. I'm going to call it the radius of a circle. So anytime I see opposite, I'm going to call it y. Anytime I see adjacent, I'm going to call it x. And anytime I see hypotenuse, I'm going to call it r for radius. So I'm just changing the letters that I'm using to abbreviate, or that I'm using, to abbreviate where these numbers go. We haven't changed any of the numbers. I'm not changing any of what we learned already, just the variables. So if we need to find the sine of theta, instead of saying opposite over hypotenuse, I'm now going to say y over r. The opposite is the y, the hypotenuse is the r. Instead of saying adjacent over hypotenuse, I might refer to it as x over r. And instead of saying tangent is O over A, I'm going to call tangent y over x. Oh, which is r. No, it's not r. I'm sorry. It's y over x. Just ignore what I'm talking about. It's y over x because the tangent is the OA, right? Okay. And then we have from there our 6 reciprocal ones. Who remembers sine? What's a reciprocal sine? Yep. Cosecant. Remember, we have to have just one co. So CSC, cosecant. Oops. And cosecant is going to be r over y. Cosine is secant, and that's going to be r over x. And then cotangent is x over y. Okay, so the reason why I just gave you these letters is so that we can answer the next 4 questions. If we weren't going to answer the next 4 questions, I'd probably never change the letters. But answering the next 4 questions, knowing the y, the x, and the radius is going to be very helpful. So what we're going to do is we're going to sketch on the coordinate plane the angle that's given. And then we're going to find the 6 trigonometric ratio of each. And there's a vocab word right here, which I'll tell you in a moment. Quadrantal angle. Each quadrantal angle. So where is 0 degrees? Where's 0 degrees? Ariana, do you know where it is? Which side of the x-axis? Positive or negative? The positive x-axis is 0 degrees, right? So here's my initial side, and here's my terminal side. They are the same. So do I have a triangle? I do not have a triangle, but I do have an ordered pair. I have an ordered pair right here. It is at x, comma, what's my y value at this ordered pair? It's on the x-axis. What's my y value there? 0. So I have an ordered pair. So if I'm asked to find sine, cosine, tangent, and then we will also find the other 3. But if I'm asked to find those, I now have the x and the y, which are the opposite and the adjacent. I have those. Okay, so x and y that we just said above is exactly the same as the adjacent and the opposite. So if you have what is memorized for sine, sine is OH, we know the O is now the Y value. So it's going to have a 0 on top. Now we need to know the H. And up above, I talked about the H being the radius of a circle. So if I have a circle here, what is my radius? 0? That would be no circle. It's got to have a length. So if I start at the origin and I work my way out to the end, what is the length of that horizontal line? What is it? No, there's no numbers here. You're not going to give me a number. You're going to give me a letter. Tessa, it is x. From origin to this endpoint, that is x long. I don't know what x is. I can make up numbers, but it's x. So in this case, our x and our radius are exactly the same length. So when I do opposite over hypotenuse, which is y over r, maybe I should write y over r so we get used to seeing it. I'll have 0 over x. And these are things that you should know. If you have 0 on top of a fraction, you divide by a number, what answer do you always get? You get 0. If 0 is on top, you're going to get 0. So that is the sine of 0 degrees. The answer is 0. Now we're going to do the cosine and hopefully go a teeny bit faster. The cosine is normally adjacent over hypotenuse, but we are above in our example above, we have adjacent is now the x and the hypotenuse is now the r. So I'm going to look at my picture. My x is x and my r is how long in the picture? How long is the r? R equals x. So the x equals x and the r equals x. What is the cosine? 1. Tangent of 0 degrees. Tangent is y over x. So I need the y value, which I get from the ordered pair, 0, and I need the x value, which I get from the ordered pair, x. 0 over x is 0. See, these are not going to be complicated numbers. My answers were zeros and ones. Now we're going to flip them. So if I go and I find my cosecant theta, I can, if I need to, write that as r over y. But since I already have numbers here, I'll just write it as x over 0. And what do you get when you divide by 0? When you have a number over 0, what happens? You can't do it. It's undefined. So I'm going to write down undefined. Undefined. Secant 0. Secant 0, we're going to take our cosine and flip it. So I'll have r over x, which is the same thing as x over x. If I flip the number 1, I still get the number 1. And the cotangent, we're going to flip tangent, x over y, which is x over 0, which is undefined. Now, I want you to be able to make shortcuts with this. If you have 0, what will the reciprocal be? You've seen it twice now. Undefined. It goes backwards too. If I have undefined, what is the reciprocal of undefined? 0. So we want to connect those together. When I flip 0 or I flip undefined, they equal each other. Okay, the next one is 90 degrees. Again, it's called a quadrantal. It's not in the quadrant. It doesn't make a triangle. So we've got our initial side and then our terminal side. But you can't go x, y and create a triangle because what is x at this point? What's x at this point? 0, and then y is whatever y is. I don't know. So we're doing the sine of 90, the cosine of 90, tangent 90, and then we'll do cosecant 90, secant 90, and cotangent 90. So if I look at 90 degrees being on a circle, what is the radius of that circle? From the center straight up is how long? Warren, do you know? Huh? No. Okay, so from here to go to here, what value do I use in the ordered pair? If I were graphing it, to go from here to here, graphing it, what value would I use? You don't know how to graph an ordered pair? No. Yes, you do. Please don't talk to me like that. I'm graphing the ordered pair. We're graphing the ordered pair 0y. Okay? So when I go from here to here, like you always started graphing ordered pairs at 0, 0. So when I go this way, what am I using to know how far to go? I don't know. Okay. What if I told you that this ordered pair was 0, 6? Could you tell me how long that is? 6. Yes. So now can you tell me how long this is? I have no clue. Okay. Warren, if this is 0, 10, how long is this? 10. Where are you getting those numbers from? The 6 and the 10, you were totally right on those. Where are you getting those numbers from? I don't know. Yes, you do. Where are they from? They just like magically came to you? No, they did not. We got a problem because we have 2 stubborn people right now going against each other. Oh, yes, Warren, that's totally right. Warren said it came from the y coordinate. He saw it right there in that spot. So up here, it's the exact same thing, only I don't know what y is. I can make up a number. It doesn't even matter if you make up a number. All of these answers are going to be the same if you make up a number. I could make that 0, 10 if I want. And I could say this is 10. It doesn't matter if you make up a number. I'm doing it using letters because we're in algebra, and algebra is when you start using letters, but that length is y long. That's how long it is, whatever y is. So we're going to go over and we're going to find the sine. And the sine is the y value over the hypotenuse, over the radius. It's y over r, which is y over y, or you could say 10 over 10 if you gave it a value. What is that answer? 1. The cosine is going to be x over r. When we look at cosine, the x value, and it's 0. Doesn't even matter what r is. Yeah, it doesn't matter what r is. Your answer is going to be 0. If you have 0 on top, your answer is going to be 0. And then we do tangent, and tangent is x. Nope, tangent is y over x. And I put my y in, which I don't care if you use y or if you use 10. It does not matter, because as soon as I put my x value in of 0, what is the tangent? Undefined. So I'm telling you guys, like, I'm using x's and y's right now, but you could totally make up a number for x or y as long as you have 0 in the other spot. This will work for every single one of those as long as you have a 0 in the other spot. Okay, so now we're going to flip them. I don't even need to use x, y, or r. I'm just going to flip what I already have. So if the sine of 90 is 1, then what's the cosecant of 90? Bless you. Was that a sneeze? Oh, okay. What's the cosecant? I'm sorry, what's the reciprocal of 1? It is 1. Done. If the cosine of 90 is 0, reciprocate that. Undefined. And if the tangent is undefined, reciprocate that. What's the cotangent? 0. See, those 3 are super easy. The first 3 aren't that hard either. Let's look at 180 degrees. So 180 degrees is going to end on the negative x-axis. My ordered pair would be negative x, 0, because there's nothing for the y. What will the radius be? What will the radius be, Nina? How long is that? From 0, 0 to here. It's the length of that. Okay, so I'm just going to take your negative away. The length is x. The negative is telling me which direction to graph, but when we talk about length, the length is x. Okay? And I'll just put a little side note over here because I'm talking about that right now. The radius of a circle is always positive. So that'll be your R value or your hypotenuse. We did talk about the hypotenuse is always positive. We talked about that last time. So the rules work when we're on the quadrantal as well. Okay, so we're going to do sine of 180 degrees, cosine 180, tangent 180. So sine would be y over r, cosine is x over r, and then tangent is y over x. I don't know if you guys noticed this at all, but it worked when I was using opposite and hypotenuse and adjacent, all that stuff too. But the tangent is the top of the sine over the top of the cosine every single time. So sometimes when I forget what tangent is, I'll just look at sine, cosine, y, x in order. That's just like a little way to help you try to remember. Okay, so we're going to do the sine at 180 degrees. The sine is y, which is 0 over the radius, and it doesn't even matter what I write at that point, because if it's 0 over something, what is it going to be? 0. It is 0 over x if that matters. The cosine is x over r. My x value is negative x. That's in the x spot, negative x in the ordered pair. My r value is positive x. So the cosine is -1. And then tangent, y over x. So the y value is 0. I don't even need to finish, because if I have 0 on top, the answer is going to be 0. Okay, then we're going to flip, flip, flip. Cosecant, secant, and cotangent. Okay, Ryan, what will be cosecant?
Undefined.
Perfect, undefined. Ella, what will be secant? Great, -1. And Sophie, cotangent? Undefined, excellent. Okay, I'm going to skip this third one. Hopefully that's enough information to find the third one. Or fourth one, I guess this fourth one, sorry. And then we're going to look at this tiny little piece of information. This is not going to be necessarily a question, but it's super helpful if you know all the stuff. A lot of the stuff we're writing today is just kind of helping you kind of solidify the stuff you've already learned, okay? Which trigonometric ratios are positive or negative in which quadrants? So our quadrants are 1, 2, 3, and 4. Those are our quadrants. And we're going to make a list of what's positive and what's negative in each quadrant. In quadrant 1, does anybody want to say, let's see, if we're using, hold on, I'm going to go back to here. If we're using x's and y's and radius is always positive. In quadrant 1, what's going to be positive from putting y over r, x over r, y over x? What's going to be positive in quadrant 1? All of them. Every single one of them. You don't have any negative numbers in quadrant 1. So if you are in quadrant 1 and you're asked to find the sine, cosine, tangent, or cosecant, secant, cotangent, it's going to be positive every single time if you're in quadrant 1. All of them are positive. Now, before I go over quadrant 2, how do we graph something in quadrant 2? I'll throw a dot up there. I'm going to erase it, but I put a dot there. How do I graph that? I started 0, 0, and where do I go first? I go negative x, and then I go positive y. At any point in this quadrant, we have negative x, positive y. So when I go and I look at my list, maybe I should copy this list so I don't have to keep going up and back and forth. Let me copy this list real fast. Oops. Okay, there we go. When I look at my list of what's x and what's y, anything that has a y will be positive. Let me rephrase that. Anything that doesn't have an x will be positive. It doesn't have an x. But if it has an x, it's going to be negative. So let's look, what's going to be positive in the second quadrant? What up here doesn't have an x? Sine and cosecant, because that's just sine flipped. So that means what's going to be negative in quadrant 2? Anything with an x. Cosine and tangent, and then the flipping those as well. I don't usually write the flipping ones, but I just usually write the main ones. So that's quadrant 2. If you're in quadrant 2, only sine or cosecant will be positive. Quadrant 3, if I go into quadrant 3, I have negative x, negative y. So for quadrant 3, what can possibly be positive if I have a negative x and a negative y? I have a negative x and a negative y. Out of all these ratios here, where can I get positives with a negative x, negative y? I hear somebody, but I have no idea where it's coming from. Nina? Tangent and cotangent, because if I put a negative over a negative, what does that give me? Positive. That's the only way we'll get positive is if we have two negatives on top of each other. So tangent and cotangent are the only ones that are positive in the third quadrant. Oops, I didn't write positive. And so negative would be sine and cosine. And then they're reciprocal ones. Okay, and then in the fourth quadrant, what can be positive? My fourth quadrant ordered pair would be positive x, negative y. In the fourth quadrant, positive x, negative y. So what can be positive in the fourth quadrant? Positive x, negative y. So it can't have a negative y in it. What doesn't have a y? Nina, what doesn't have a y? Cosine. So positive is cosine. And then also secant. The stuff with y, the negatives, would be sine and tangent. And then there's this like acronym, I think the right word is acronym. You know, kind of like SOHCAHTOA. Is that an acronym? Or is SOHCAHTOA an acronym? Or PEMDAS? Am I using the correct vocabulary word, acronym? Where you like use the first letters and make something like a saying. Okay, so there's a saying. It's all students take classes. All students take classes. In the first quadrant, all are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. In the fourth quadrant, cosine is positive. So that's just in case you forget about your positive, negative stuff. You don't have to have all that memorized if you're drawing your triangles correctly. But the reason why I wanted to go over that is there's just a couple questions that are find the exact values of the 5 trigonometric ratios not given. And then what they've done is they've given you one of the ratios. So we're going to find all of them. They've given us one. So we're going to find sine, cosine, tangent, cosecant, secant, cotangent. They've given us secant, negative 17 over 15. So how do we find cosine if we know secant? We flip them, right? Negative 15 over 17. So now I'm going to draw a picture. And I have to read these clues and understand where this is. So the first thing that I'm noticing is that cosine is negative. The first thing I'm noticing is that cosine is negative. And then I'm also reading up here where it says sine is greater than 0, meaning sine is positive. So we're trying to find which quadrant has sine values positive, but cosine's negative. So in quadrant 1, everything is positive. Does that fit what I'm doing here? Nah, it's not quadrant 1. In quadrant 2, what is positive? All students take classes. Sine is positive, and is that what I want? And so cosine is negative in quadrant 2. That's where I'm going. So I'm going to put a point out there. And then I'm going to graph that point by doing from 0, 0, go to the x, go up to the y, and make that triangle with theta. So the stuff that we're already doing. We know that the secant, or I'm going to go to cosine. Cosine is negative 15 over 17. So the negative 15 and the 17 are two of the sides. Which side is the 17? The hypotenuse. Remember, the hypotenuse is the longest side. So the hypotenuse is 17. The x, so cosine is x over r. The x is the, or it's adjacent. You can look at it either way here. Adjacent over hypotenuse. You can look at it either way. So that will be negative 15. What's the third side? Hint, it's a triple to save you some time. What's the third side? Who knows it? Did a whole Simon on triples. What? It is not 5, but thanks for saying something. It is 8. Yes, 8. So now at this point, we can fill out the rest of it. 8/17, 17 over 8. Tangent will be negative 8/15. Cotangent will be negative 15/8. And that's just using the formulas that we already know, SOHCAHTOA. The only time we really need to use that R thing would be if you're doing the quadrantal angles, the 90 degrees, or when we don't have a triangle to draw. Okay, I'm going to quickly go through another one of these. So they're telling me cosecant is negative 13/5. So right now I know that cosecant and sine are negative. You look over here and you see that cosine is less than 0, so that is saying that cosine is negative also. So if I use all students take calculus, or take classes, sorry, all students take classes. If I use that, those are the ones that are positive. Oops. These are the positives. I know that it can't be this quadrant because all are positive and both of these are negative. Can't be this one because sine is positive. Can't be this one because cosine is positive. So it has to be the third quadrant. I'm going to draw a triangle in the third quadrant. So I'm going to start at 0, 0. I'm going to go left down. My sine has to be negative 5/13. So negative 5 will be the y value, the opposite, and 13 is the hypotenuse. What is the missing side? It's a triple. I've got 5 something 13. All right. Take a guess. I can't hear your guess. 15? It's got to be smaller than 13 because 13 is the hypotenuse. 12. It's 12. 5, 12, 13. 5, 12, 13. Now, if you did not know that, you can waste your time and do the Pythagorean theorem. If you know it, you don't have to do the Pythagorean theorem. So then to find the rest of these, cosine theta is, oops, it's not 12, it's negative 12. Negative 12 thirteenths. And then secant theta will be negative 13 twelfths. Tangent theta is 5 twelfths. Cotangent is 12 over 5. I'm not going to get to this part down here. This part right here is finding just what theta makes this true. I'm not going to get to it. So in your assignment, there are some questions like this, and I'm going to leave those there as a challenge that if I were to put something on the test, it would be extra credit for sure. Okay? It really isn't hard. I just didn't get to it, and I don't want to take any more time. I want you guys to work on your review in class so I can see what questions that you have before I see you next time. Okay? So open up your review. Start working on it. If it's something that you're like, oh, this is really easy, go find the new stuff and work on that first. That way I can answer questions. The new stuff would be sine, cosine, tangent if it's on the axes, the quadrantal. And then this thing that we just did here at the end is new. That's it, though. That's really all that's new.